Now let's apply the equations and relationships that I've described in the two former videos as related to string theory. If the Q point is only relative to an isolated vector or M field, whether it's right or left, then the closed part of the string cannot extend beyond this topological state. In other words, if I have just one real object in front of one mirror, the reflected information on this side cannot be extended recursively. It solely exists on the topological or the surface of the mirror as a one-dimensional superficial image. So when a sole M surface, we can refer to as a manifold, is isolated, that is, there is no relationship or entanglement between two surfaces but just one in and of itself, then the information on its surface cannot undergo recursion. This means that if we don't have or do not have the relativity between reflective surfaces, two vectors, reflective sides of strings, then no string on either or side can propagate. The information solely exists on a surface, and where any interior is precluded as occurring, any virtual interior is precluded as occurring or possible. However, when two reflective medium, two mirrors are relative to each other, and of course both reflecting the same real object, quantum information in between, then due to this entanglement of information can now be virtually extended or propagated via the recursive mechanism. One isolated mirror, you won't have that recursion. You will not have that extended string. You only have a point to a string, a potential ability for a point of a string to be extended. That potential has to do with whether or not another mirror comes into relativity to it. When another mirror comes into relativity to that point, another point simultaneously emerges here, and due to the relativity, there's two virtual extensions of the reflected information that happen recursively on both sides, two different directions. So I'm explicitly stating that it's the very phenomenon of entanglement that results in information being extended from a real surface through a virtual function. And we can recall these virtual functions, the virtual timeline, and as expressed as the matrix on both sides. So we're seeing that entanglement is inseparably linked to the propagation of information from the surface into matrices, into virtual interiors, and this recursive phenomenon, this recursive mechanism, or the virtual space that appears in both mirrors, represents two space-time continuums facing each other. And we could actually refer to them as two alternate forms of each other, and we'll discuss that further on into my theorem. So as entanglement is inseparably linked to the propagation of information, entanglement is also necessary for the extension of the strings from the surfaces of the manifolds into the virtual infinite matrices. Infinite one direction to the right, infinite another direction to the left. Two mirrors. The real object between the two mirrors represents the open part of the string, and of course where the mirror starts here and virtual recursion, and mirror starts here at virtual recursion, represents a continuation of that information from the open part of the string due to reflective surfaces facing each other. So the points of the strings represents the first beginning when information emerged on the surfaces. So all recursive information is derived from this point on the mirror, this first body of information. That recursive function, or that recursive space, will not exist if you remove one mirror from the other. It instantly vanishes or disappears. As well, if you have those two relativities of two reflective surfaces, then not only do you have a beginning to the point of the reflective recursive systems on both sides, the beginning point of the string, which represents the mirror surfaces, but you also have an infinite stretching of the informational lattice or string from the surfaces through virtual recursion. So the only observable, measurable process that can explain the strange entanglement potential, and we're going to come to understand that this entanglement phenomenon is derived from and related very implicitly to the Heisenberg uncertainty principle. But the only observable, measurable process that can explain this entanglement and as well both the emergence of closed strings, the emergence of first point reflective things on the event horizon of the surface, and subsequent emergence of recursive matrices, we're coming to understand that the only thing that can cause this entanglement to occur is the principle or property of recursion. So both M fields, though both M fields, mirror to the right, mirror to the left, are relative to each other, and reflecting the same information in between the mirrors, and we refer to this information in between as the open part of the string, and we'll go further and elaborate on the implications as it involves the Higgs branch as linking both surfaces or both manifolds with matrixial interiors. These two M fields, though they're relative to each other, are not equal in the strictest sense. And I've explained that earlier, but I'll elaborate on that. Their differences are defined by the fact that one surface to the left will reflect half of the real object, and the other surface will reflect the other half. Now this is just stating or talking about the state of information on the surfaces relative to each other. One will reflect half the real object, the other will reflect the other half of the real object. So these smooth manifold conditions of information, in other words, the light ring that comes from a light source shining to a mirror, spreads uniformly and evenly along the surface as the light ring expands and contracts. So this is a smooth state of information and a smooth state of the flow of information. Even though the smooth manifold conditions or the surface depiction of information spreads uniformly, this is different from the more perturbative aspects of their interiors, which are defined as recursive. So here we're showing a distinction between the smooth flow of information horizontally spread across the surface of the mirror, and then we have a perpendicular flow of information, recursive, and therein lies the perturbative, vibratory, frequency, wave, all of these other attributes, inertia, gravity, intensity, vibration, expansion, contraction, all of that is a separate flow, recursive flow, that runs opposite the direction of the smooth flow on the surface. So despite that the information on the surface of both manifolds is the same as it regards reflecting the same real object, they're actually reflecting two different sides of that object. And then again, this is the expression of the relationship of the symmetry between mirror right and mirror left as it's related to the surface. But some very strange and very profound things happen whenever the entanglement is established between two mirrors, and what happens with the information as it's recursively represented. It changes the fact that both mirrors are confined to only reflecting one side of the object. Recursion changes that in both sides of the matrices. So beyond these surfaces and when the recursion of information emerges and exists in both matrices, both sides of the equation, it is mathematically verifiable that these recursive matrices, though separate, are sharing information back and forth to each other. And here's where, again, the strong, very robust concepts and principles that's extracted from what we're seeing as it regards entanglement. All of these aspects of entanglement that we're seeing but not fully understanding fit very neatly and very concisely in the property of recursion. So the recursive information on the right side and the recursive information on the left side, they're actually sharing information to and from each other. And we'll see this literally when we start depicting in more of a dimension, more of an understandable way when we place two mirrors together and start viewing how these changes occur. So this means that regardless that the surfaces are reflecting two sides of the quantum sphere, two separate sides, when recursion ensues on both sides, the information of the right or the left mirror is sent to the information of the right mirror or vice versa, and it's expressed within the interior of the right, even though the information on the surface of the left is not the same as the information on the surface